So here is another question. So it is given, represent minus 104 in sign magnitude 1s complement and 2s complement form using 8-bit format. So here, before doing that, we'll first represent plus 104. So first we have to split it into parts with powers of 2. So we can split it as 104 as 64 plus 32 plus 8. Yes, that is 104. Yes. So 64 is 2 to the power 6, 32 is 2 to the power 5, and 8 is 2 to the power 3. Then we'll write the weights 8-bit formats. So starting from 7, 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. Okay, 2 to the power 6, it will be 1, 2 to the power 5, that will be 1, 2 to the power 3, that will be 1. So 0, 0, 0, 0, 0. Okay, so if you are a complete, you are starting with this whole concept, you proceed with this method. Okay, and as you practice more and more questions, you gain more and more expertise on writing the different binary representations. Then you can write it just by looking at the number. You can do this splitting in your head and you can write the binary representations as it is. But if you are getting started with it, if you are in the intermediate stage, I suggest you follow this method to avoid mistakes. Okay, so this is the binary representation of plus 104. So if you see here, this MSB bit, it is 0. So the sign bit, so it represents a positive number. So minus 104, we can represent it just by changing this MSB bit to 1. So it will become 1, 1, 1, 0, 1, 0, 0. This is minus 4 in sign magnitude form. So this is the first method, which is the sign magnitude method. Okay, this is minus 4 in sign magnitude form. 111, 01, 000. Next is the 1s complement method. So in 1s complement, what we'll do, so 4 is represented as 0, 11, 0, 1, 000. So minus 104 will be represented as the 1s complement of this. That is, we'll change the 0 to 1 and 1 to 0. So it will become 1, 0, 0, 1, 0, 1, 1, 1. Okay, 100, 10, 111. Okay, this is the 1s complement form. Okay, 1001, 0, 111. Next is the 2s complement method. So in 2s complement, what we'll do, we'll write the 1s complement representation, which is this 1 0 0 1 0 1 1 1, and we'll add a 1 to the LSB. Okay, so this is the 1s complement, and this is 1 added to the LSB position. Okay, so we have 1 plus 1 0 with a carry of 1, again 1 plus 1 0 with a carry of 1, 1 plus 1 0 with a carry of 1, 1 plus 0 1 1 0 0 1. This is the 2s complement form. So here you can use the shortcut method also. So here we have this plus 104 represented as 0 1 1 0 1 0 0. So here what we'll do is we'll start from the LSB position and we will move until we arrive at the first 1 bit. So up to this position. So we'll copy the bits as it is until we reach the first 1 bit. So we'll copy the bits as it is. It is 1 0 0. Now these remaining bits, okay, let me use a different ink. So these bits, remaining bits, will take the 1s complement or will invert them. So 0 will become 1, 1 will become 0. So this is the 2s complement representation, the shortcut method. So same as this, 1 0 0 1 1 0 0. Okay, 1 0 0 1 1 0 0. Here also 1 0 0 1 1 0 0. Same. Okay, same. So this is the shortcut method of calculating 2s complement directly from the positive sign magnitude. You start with the LSB, you move towards the left until you arrive at the first 1 bit. You copy the bits as it is up to the first 1 bit, including the first 1 bit, and then after that the remaining bits you take the 1s complement, you invert them. So we'll get the 2s complement directly. Or if you don't remember this trick, you can use the usual method, that is first take the 1s complement and then add 1 to the LSB. Okay, so either way you will get the same result.